Good morning, students. Now we discuss about the application of first derivative exercise 7.6. Now we discuss about the examples of exercise 7.6. Now extreme value theorem. Now we discuss about the extreme value theorem, absolute extrema. You see this diagram. The curve is a up and down. So the upper that means the upper point. The upper point we denoted the derivative is dy by dx equal to, this is a flat, so it is a dy by dx equal to 0. The down portions dy by dx, the value is less than 0. The value means the derivative value is, it comes to minus, so minus we represented the less than 0. So this is the curve. Here A point, here B point, here C point. So in this point the derivative value is 0, and here the lower point the derivative is less than 0. Less than 0 means its value is minus. So the curve equation is y equal to f of x. You see, a procedure for finding the absolute extrema of a continuous function f of x on closed interval a comma b. So now we find out that means the procedure. Now we see about the procedure for finding the absolute extrema of a continuous function. The step 1, find the critical numbers of f of x in a comma b. So first we find out the critical numbers. Next one, evaluate f of x at all critical numbers and at the end points a and b. That means in the step 2, first step 1, find out the critical numbers. Step 2, evaluate the critical numbers and the end points a and b. Step 3, the largest and the smallest of the values in step 2 is the absolute maximum, also absolute minimum. That means the largest value we taken we call as it is a maximum, absolute maximum. Smallest value we call as absolute minimum of f of x respectively on the closed interval a comma b. This is a procedure for we find out in the absolute extrema. Next we discuss about the monotonic functions. Monotonic means we call it is a monotonic. There is a two types. One is increasing or decreasing. So both increasing and decreasing we call the monotonic functions. You see, monotonic functions means it is increasing function or decreasing functions. Both the function we call monotonic functions. You see, this is the curve. The curve is represented by the equation y equal to f of x. So here this is the upper point, there is a flat point. That point the derivative is equal to 0, that value is 0, and here the lower point in the derivative dy by dx less than 0. Less than 0 means here strictly decreasing. Less than 0 represented the strictly decreasing. So you see the definition, a function that is completely increasing or completely decreasing on I is called monotonic I. That means the increasing and decreasing functions, or increasing function or decreasing function we call the monotonic function on I. Now we discuss about the exercise 7.6. First problem, find the absolute extrema. Find the absolute extrema of the following functions on the given closed interval f of x equal to x square minus 12x plus 10 interval 1 comma 2. So you see the question, they ask about find absolute extrema of the following. Extrema means it represents the maximum and extrema maximum and extrema minimum. So for of the following functions. So they gave the functions f of x equal to x square minus 12x plus 10 and interval is 1 comma 2. From this we find out the absolute extrema. So first step, I write the given function f of x equal to x square minus 12x plus 10. So here I write f of x is continuous on 1 comma 2, closed interval 1 comma 2. In the next step I find out the derivative. So f dash of x equal to, I differentiate the x square. Differentiation of x square is 2x minus differentiation of 12x is minus 12. So next step I substitute, that means I take f dash of x equal to 0. So 2x minus 12 equal to 0 means 2x equal to 12. X equal to, that means we divide this 2, divide the 2, then 12. So x equal to 12 by 2. 12 by 2 means 6. X equal to 6. So x equal to 6 is only critical point. The end points, so x equal to 6 is the critical point. The end points are, you see the interval, there is two end points, one is 1 and another one is 2. So the end points are x equal to 1 and x equal to 2. So the next step, first I take when x equal to 6. So the critical point x equal to 6, I substitute in the function f of x equal to, we know this is a given function, I substitute x equal to 6 here. So f of 6 equal to 6 square minus 12 into 6 plus 10. I write it here, 6 square minus 12 into 6 plus 1 plus 10 here plus 10. So f of 6 equal to 6 square means 36 minus 12 into 6 are 72 plus 10, which implies, that means again I subtract, that means 36 plus 10 46, 46 minus 72 minus 26. Therefore f of 6 equal to minus 26. Next, when x equal to 1, next I substitute the end points, x equal to 1, x equal to 2. So when x equal to 1, I substitute this value in the function, that means f of x equal to x square minus 12x plus 10. That function I substitute x equal to 1. So f of 1 equal to x square means 1 square minus 12x, 12 into 1 plus 10. So 1 square means 1, 12 into 1 minus 12 plus 10. So 11 minus 12 minus 1, f of 1. Next, when x equal to 2, again next I substitute second end point x equal to 2 in the function, f of 2 equal to x square, 2 square minus 12 into x, 12 into 2 plus 10. So the next step, 2 square is 4 minus 12 into 2, 24 plus 10. So the next step, f of 2 equal to 4 minus 24 plus 10, 14 minus 24 minus 10. So from this I find out the absolute. They ask about the question is find absolute extrema. Absolute extrema means absolute maximum, absolute minimum. So you see that we find out the 4 values. That means the first value is f of 6 equal to minus 26, f of 1 equal to minus 1, f of 2 equal to minus 10. So from these 3 values we choose the absolute maximum. Absolute maximum is the highest value, absolute minimum is lowest value. So you see, so from the three values we choose absolute maximum is minus 1. Minus 1 is the highest value among the 3 values. That means we know the 3 values. The first one is minus 1, minus 10 and minus 26. So this is the highest value is minus 1 and the absolute minimum value is minus 26. So this is the minimum value, this is the maximum value. Second subdivision, f of x equal to 3x power 4 minus 4x cube. The interval is minus 1 comma 2. You see, this is the given function, f of x equal to 3x power 4 minus 4x cube. Here f of x is continuous on minus 1 comma 2. So now I find out the derivative. So f dash of x equal to, that means 3 into, I differentiate the x power 4. Definition of x power 4 is 4x cube. 3 4s are 12, 12x cube minus 4 into differentiation of x square is 3x square. So 4 3s are 12, 12x square. So f dash of x equal to 12x cube minus 12x square. So the next step I take f dash of x equal to 0. F dash of x equal to 0 means the 12x cube minus 12x square equal to 0. So the next step I take the common factor 12x square. So 12x square remaining I take the 12x square from this first term. So the remaining term is x minus 12x square I take out from this second term. So the remainder factor is 1. So therefore 12x square into x minus 1 equal to 0. Now I equate to each factor. Here in this equation there is a 2 factor. First factor is 12x square, second factor is x minus 1. So every factor I take to 0. So 12x square equal to 0, x minus 1 equal to 0. 12x square equal to 0 means number not equal to 0. So x square equal to 0. Here x minus 1 equal to 0 means the minus 1 I write in the RHS. So x equal to 1. Therefore x square equal to 0 means x equal to 0, x equal to 1. Therefore x equal to 0 and 1, x equal to 0 comma 1 belongs to minus 1 comma 2. So these both the values lie in the interval. So the critical points are, these are critical points, x equal to 0 and x equal to 1. So the end points are minus 1, 2. So now I substitute x equal to 0 in the function. Now I substitute x equal to 0 in the given function. We know the given function, f of x equal to 3x power 4 minus 4x cube. Here I substitute x equal to 0. So f of 0 equal to 3 into 0 power 4 minus 4 into 0 power 3. So 0, f of 0 equal to 0, x equal to minus 1. X equal to minus 1 means f of minus 1 equal to 3 into minus 1, that means 3 into minus 1 whole power 4 minus 4 into minus 1 whole power 3. So this is 3 minus 4 into minus 1, minus into minus plus. So 3 plus 4, f of minus 1 equal to 7. Next x equal to minus 1, next x equal to 1, here I substitute plus 1. So f of 1 equal to 3 into 1 power 4 minus 4 into 1 power 3. So 3 minus 4 minus 1. Next x equal to 2. Next I substitute x equal to 2. X equal to 2 means f of 2. F of 2 equal to 3 into 2 power 4 minus 4 into 2 power 3. So 2 power 4 means 2 2s are 4, 4 2s are 8, 2s are 16, 16 into 3s are 48 minus 8 into 4 32. So 48 minus 32 is 16. Therefore f of 2 equal to, that means 48 minus 32 is 16. Therefore we find out the values. So the absolute maximum value is 16 and the absolute minimum value is minus 1. Which one is lowest value? That value we taken absolute minimum. Which value is greater value? That value we taken maximum value. Therefore absolute maximum value is 16, absolute minimum value is minus 1. Third subdivision, f of x equal to 6x power 4 by 3 minus 3x whole power 1 by 3, interval minus 1 to plus 1. So f of x equal to 6x power 4 by 3 minus 3x power 1 by 3. F of x is continuous on minus 1 to plus 1. So f dash of x equal to, that means we take the first derivative, f dash of x equal to 6 into, I differentiate the x power 4 by 3. So 6 into 4 by 3 into x power 4 by 3 minus 1, minus 3 into, differentiate the x power 1 by 3. So 1 by 3 into x power 1 by 3 minus 1 equal to 24. That means here 6 into 4 by 3 means 24 by 3 into x power 4 by 3 minus 1. Next 3 by 3 x power 1 by 3 minus 1. So 3 divide the 24. So 8 3s are 24. 8 x power 4 by 3 minus 1 means we just cross multiply. That means 4 minus 3 by 3. 4 minus 3 is 1 by 3. So I write it here 1 by 3. Here I write x power 1 by 3. 8 into x power 1 by 3 minus 3 3s are cancelled. So x power 1 by 3 minus 1, I keep it as it is. No change here. So I am not doing any cross multiplication. So x power 1 by 3 minus 1. In the next step I take x power 1 by 3 from this factor. So from this term. So x power 1 by 3 into the remaining factor I write. So I take x power 1 by 3 from this, from the first term. So remaining factor is 8. I write it minus, next I take the x power 1 by this x power 1 by 3 minus 1. I write it x power 1 by 3 into x power minus 1. So I take the x power 1 by 3 from the second term. So remaining factor is x power minus 1 equal to, the next step, x power 1 by 3 into 8 minus x power minus 1. I write this minus 1, it comes to the denominator. So 1 by x, x power minus 1, I write it 1 by x. Therefore just I doing the cross multiplication, x power 1 by 3 into 8x minus 1 by x. The next step, x power 1 by 3 into this, again I write this denominator x, I write in the numerator. So x power 1 I write in the numerator means x power minus 1 into 8x minus 1. The next step, both the base here x power 1 by 3, x power minus 1. So I add the power, x power 1 by 3 minus 1 into 8x minus 1. In the next step I just cross multiplying 1 minus 3 by 3. So 1 minus 3 by 3 means 1, that means minus 2 by 3. So 8x minus 1. So next f dash of x equal to x power minus 2 by 3, 8x minus 1. So let f dash of x equal to, this is f dash of x. Now f dash of x equal to 0. F dash of x equal to 0 means this is x power minus 2 by 3, 8x minus 1 equal to 0. So here two factor. First factor is x power minus 2 by 3. Second factor is 8x minus 1. So now each factor equal to 0. So x power minus 2 by 3 equal to 0 means x equal to 0. 8x minus 1 equal to 0 means 8x equal to 1, x equal to 1 by 8. Therefore f dash of x f dash of x does not exist for x equal to 0, because we take x equal to 0 means it comes to infinity, 1 by 0 infinity. So the critical points are x equal to 0 and x equal to 1 by 8. The end points are, here you see the limit, the end point is minus 1 plus 1, so the end points are minus 1 plus 1. Now we find out the values for x equal to 0, x equal to 1 by 8, x equal to minus 1, x equal to 1. Next I substitute x equal to 1 in the function, in the given function. F of 1 equal to 6 into 1 power of 4 by 3 minus 3 into minus 1 whole power 1 by 3. So 1 power 4 is 1, anything power anything, that means 1 power anything number is 1. So here 1 power 4 is 1. So again minus 3 into that means minus 3 into minus 1 whole power 1 by 3. So here there is no minus 1 plus 1, so plus 1 power 1 by 3. So 1 power anything is 1, so therefore 6 into 1 power 1 by 3 minus 3 into 1 power 1 by 3. So again we write it, this is 6 of anything power 1 is 1, so 1 power 1 by 3 is 1, 1 power 1 by 3 is 1, so 6 into 1, 3 into 1, 6 minus 3, 3. Therefore from this we find out the absolute maximum, absolute minimum. Which value is highest value, that value we taken the absolute maximum. Which value is minimum value, that value is we taken the absolute minimum. Therefore absolute maximum is 9 and absolute minimum is minus 9 by 8. So next fourth subdivision, f of x equal to 2 cos x plus sin x in the interval 0, pi by 2. Therefore here small f of x only given, therefore small f of x equal to 2 cos x plus sin 2x. So small f of x equal to 2 cos x plus sin 2x. So f of x, small f of x is continuous on 0, pi by 2. So now I find out the first derivative. So f dash of x equal to, I differentiate the cos x, so minus sin x, minus 2 sin x plus I differentiate the sin 2x. So sin 2x is cos 2x and I differentiate the 2x is 2. So 2 cos, here 2x only come, so 2 cos 2x. So here 2 common, so I take the 2 from this term, so 2 into cos 2x minus sin x. The next step I take f dash of x equal to 0. So f dash of x equal to 0 means 2 cos 2x minus sin x equal to 0. So cos 2x minus sin x equal to 0 means, now I substitute cos 2x means 1 minus 2 sin square x. So I substitute here 1 minus 2 sin square x minus sin x equal to 0. So in the next step I write it, that means now I write it 2 sin square x plus sin x minus 1 equal to 0. So I just change the sign. So next step 2 sin square x plus I add and subtract the sin x. So plus sin x minus sin x. Already there is a sin x, so 2 sin x minus sin x minus 1 equal to 0. Now first two term I take the common factor 2 sin x. So 2 sin x from the first two term. So 2 sin x. So 2 sin x means here already there is a sin square x. So remaining factor sin x plus I take the 2 sin x from the second term. So remaining factor 1. So next the last two factor, third and fourth factor, here minus 1 is common. So I take minus 1 from this last two terms. So minus 1 I take from this. So minus 1 into sin x plus 1 equal to 0. You see in the inside within the bracket, that means the inside the bracket the term is common, sin x plus 1 and the sin x plus 1. So the terms are common, so I take from the common term. So sin x plus 1 I take from the outside. So sin x plus 1 I take from the outside means the remaining factor is 2 sin x. I write it here, the second term the remaining factor is minus 1. So 2 sin x, that means minus 1 into sin x plus 1 equal to 0. Here 2 factor, 2 sin x minus 1 1 factor, sin x plus 1 is the second factor equal to 0. Now I take each factor equal to 0. So 2 sin x minus 1 equal to 0, sin x equal to, and that means so 2 sin x minus 1 equal to 0 and sin x plus 1 equal to sin x plus 1 equal to 0. Every factor I taken to 0. So 2 sin x minus 1 equal to 0 means this minus 1 I write in the right hand side, so plus 1. So therefore 2 sin x equal to 1 means sin x equal to 1 by 2. So in the next step 1 by 2 means sin, that means Sin pi by, so 1 by 2 means sin 30 degree equal to 1 by 2. So sin 30 degree I write it. Sin cancelled, x equal to 30 degree. 30 degree I represented by the pi by 6. Therefore x equal to pi by 6. So in the next factor, sin x plus 1 equal to 0, sin x equal to minus 1. So sin x equal to minus the one represented by sin 90 degree. So minus sin of minus 90 degree. So sin cancelled. So x equal to, that means I write it here sin x equal to minus 1. So minus 1 I represented by minus sin pi by 2. So minus sin pi by 2 means this minus sin pi by 2 I write it sin of pi plus pi by 2, because you see this is a pi plus means 180 degree. So here plus, so plus degree means you comes up. So it comes up means first quadrant is 0, next 90 quadrant, next 180 quadrant. You come to the 180 quadrant means third quadrant. In the third quadrant tan and cot only positive, remaining functions are negative. So sin comes to negative. So sin of pi plus pi by 2 answer is minus sin pi by 2. So for this I write sin pi plus pi by 2. The next step, sin and sin cancelled, x equal to, that means you just cross multiply pi 2 into pi 3 pi by 2. So the next step I cancelled sin and sin, x equal to 3 pi by 2 is the answer. So the next step, x equal to pi by 6. So the pi by 6 means 30 degree in the 0 to 90 degree. So but 3 pi by 6, 3 pi by 2 means 270 degree not in the interval 0 to 90 degree. So the 270 degree in the outside of the interval, so it is not lie in the interval, so we consider this value only. Therefore the critical point is x equal to pi by 6. So here the interval, there is a two end point, one is 0, one is pi by 2. So the end points are x equal to 0, x equal to pi by 2. So when x equal to pi by 6, so now I take x equal to pi by 6. Pi by 6 means 30 degrees. So f of pi by 6 means 2 cos pi by 6 plus sin into sin 2 pi by 6. So in the next step, 2 cos 30 degree is root 3 by 2 plus sin 2 and 3 are cancelled. So pi by 3 means it is here 60 degree. Sin 60 degree is root 3 by 2. So sin 60 root 3 by 2. So I just cross multiply this. That means here 2, that means new denominator 2. So I take the common denominator 2. I add the numerator 2 root 3 plus root 3. So 3 root 3 by 2. F of pi by 6 equal to 3 root 3 by 2. Therefore x equal to 0. Next value I substitute in the function. Here small f of x will come. So x equal to 0, f of 0 equal to 2 into cos 0. I substitute x equal to 0 in the given function. So f of, we know the given functions. So that means the given function is 2 cos x plus sin into 2x is the given function. So I substitute x equal to 0. So f of 0 equal to 2 into cos 0 plus sin 0. 2 into cos 0 is 1, sin 0 is 0. So 2 into 1, 2. Next x equal to pi by 2, f of pi by 2, 2 cos pi by 2 plus sin into 2 pi by 2. 2 2's are cancelled. Cos pi by 2 is the 0. So 2 into 0. So 2 into 0, 0. Sin pi is 0. So 0 plus 0, 0. So therefore we find out the three values. X equal to pi by 6, its value is 3 root 3 by 2. X equal to 0, its value is 2. X equal to pi by 2, its value is 0. Therefore here from this we find out the absolute maximum. Absolute maximum is 3 root 3 by 2 is the absolute maximum, highest value for this, highest number, biggest number. Next absolute minimum is lowest number is 0. 0 is the lowest number. So that number I take the absolute minimum, highest value I take the absolute maximum. So second problem, find the intervals of monotonic and hence find the local extremum for the following functions. So find the intervals. You see the question, find the intervals of monotonicities, and hence find the local extremum for the following functions. So they ask about the intervals of the monotonicities and find the local extremum. So the first problem here, small f of x, not capital F of x, small f of x equal to 2x cube plus 3x square minus 12x. So I write the given function small f of x equal to 2x cube plus 3x square minus 12x. Now I take the differentiation. So differentiate with respect to s. So f dash of x equal to 2 into I differentiate the x cube 3x square, 2 3s are 6, 6x square plus 3 into I differentiate the x square 2x. So 3 2s are 6x minus 12. Differentiation of x is 1 minus 12. So next step, f dash of x equal to 0. F dash of x equal to 0 means 6x square plus 6 minus 12 equal to 0. So I divide by 6. So x square plus 6 minus 2 equal to 0. Now I factorize this. X square plus 6 minus 2 equal to 0 means I write it, that means the minus 2, I take the 2 into minus 1, 2 and minus 1, I add the 2 minus 1, we get the answer plus 1, and I multiply 2 minus 1, I get the value minus 2. Therefore I take the factor x plus 2, x minus 1 equal to 0. So each factor I take to 0. So the next step, x plus 2 equal to 0, x minus 1 equal to 0. Therefore x equal to minus 2, this plus 2 I write in the RHS. So plus 2 goes to minus 2 in the RHS. So x equal to minus 2. X minus 1 I write in the RHS plus 1. So x equal to 1. Therefore the stationary points are x equal to minus 2, x equal to 1. These are stationary points. So next, so the stationary points are minus 2, 1. So I substitute in the middle of the interval, minus infinity to plus infinity, minus 2, minus 1. Therefore the intervals are minus infinity to minus 2, minus 2 to 1, 1 to infinity. These are the intervals of a monotonicity. So therefore now I write all the interval. I put the column. This is the timetable. This is the table for the interval. So interval, that means that the first interval is minus infinity comma minus 2, second interval minus 2 comma 1, third interval 1 comma infinity. The sign of f dash of x, monotonicity. So sign of f dash of x means I substitute the value in the function f dash of x. So minus infinity to minus 1, minus 2 means I substitute in the between the any value. So minus 2, I substitute minus 3. So suppose I take the minus 3, x equal to minus 3, I substitute in f dash of x. So our answer is our plus, that means it comes to plus answer. That means its sign is plus. Therefore it comes to plus means it is a strictly increasing. So I tell that it is a strictly increasing. That means I take any value from between the minus infinity to minus 2. So minus 2 before value minus 3, minus 4, minus 5. So I take x equal to minus 3, I substitute in the f dash of x. Our answer is, that means plus sign. So I take any value from this interval. So I substitute that value in the f dash of x. I get the answer plus sign. So there is a, I tell that it is a strictly increasing. Here increasing, strictly increasing. Next I take the next value from this second interval, minus 2 comma 1. So minus 2 comma 1 means it's a between value is minus 1 0. So it is a between value. So I substitute x equal to 0 means it gets the value is, I substitute x equal to 0 in the f dash of x. So our answer is x equal to 0 means it is a f dash of x means minus 12. So I substitute x equal to 0 in the f dash of x. I get the answer minus 12. Minus 12 means there is a symbol is minus. So I represent only minus or plus. What is the symbol I represented? So minus. So minus means we denote, I represent this strictly decreasing. So decreasing function. Next interval 1 comma infinity, you take any value. So 2, suppose x equal to 2, I substitute in the f dash of x. So I get the plus sign in the answer. So I denote strictly increasing. So f of x is strictly increasing on minus infinity comma minus 2, and there is a two strictly increasing point interval. One is minus infinity comma minus 2 and 1 comma infinity, and the strictly decreasing interval is minus 2 comma 1. Therefore f dash of x, small f dash of x, changes from positive to negative when passing through x equal to minus 2. So x equal to minus 2, that means it changes the from positive to negative. So and f of x is the local maximum at the point. So this value, that means the sign changes from positive to negative at the point x equal to minus 2. Therefore the local maximum f of x as a small f of x as a local maximum at x equal to minus 2, and the local maximum value is f of minus 2. So local maximum, we know that x equal to minus 2 is the local maximum, but the local maximum value is, we substitute this the f of minus 2. So I substitute f of minus 2 means you substitute x equal to minus 2 in the given function. So 2 into minus 2 whole power 3, 3 into minus 2 whole square, minus 12 into minus 2. So 2 power 3 is 8, 8 2s are that means minus 16, and next 2 2s are 4, 4 3s are 12, next minus 10 into minus plus 24. So your answer is, that means minus 16 plus minus 4 plus 20. Also since f dash of x, small f dash of x, changes from negative to positive, so small f dash of x changes from negative to positive means when passing through x equal to 1, again the f dash of x changes from negative to positive, sign changes from negative to positive at the point x equal to 1. This is the local minimum. So local minimum, the local minimum value is f of 1, small f of 1. So I substitute the given function x equal to 1. So 2 into 1 power 3 plus 3 into 1 square minus 12 into 1, 2 plus 3 minus 12. So 5 minus 12 minus 7. So local maximum equal to 20, local minimum is minus 7. This is the answer. Now we discuss about the second problem, subdivision to small f of x equal to x by x minus 5. This is a small f of x, no capital F of x. So you consider only your book problem, there is a small f of x only. So small f of x equal to x by x minus 5. Therefore small f of x equal to x by x minus 5. Therefore f dash of x equal to, this is the u by v. You see two functions in the numerator by denominator, so you apply the d of u by v. D of u by v means v square u into d, that means v into du minus u into dv. So first you taking the square in the denominator, so x minus 5 whole square, you write the denominator x minus 5, you differentiate the x, differentiation of x is 1 minus again x into differentiation of denominator, differentiation of the denominator is 1. So x minus 5 minus x plus x minus x cancelled, so minus 5 x minus 5 whole square. So not equal to, this is not equal to 0. So for all x belongs to R, f dash of x, small f dash of x does not exist at x equal to 5. Suppose I substitute x equal to 5 means 5 minus 5 0, 1 by 0 is infinity. So there are no stationary point, but there is a critical point is x equal to 5. That means no stationary point for this function, but a critical point is x equal to 5. So next, so critical point is 5, so I represent it in the number line. So minus infinity plus infinity, I put the 5 in the middle. So the interval is minus infinity to 5, 5 into infinity. Now I see the, that means now I make the table. So interval sign of small f dash of x, monotonicity. So I write it the first interval minus infinity comma 5 and 5 comma infinity. So minus infinity comma 5 means you take any value from this interval and substitute in the f dash of x. Your answer is come to minus. So suppose x equal to 4, not x equal to 4, or yes, x equal to 4. So minus, that means minus infinity means all the negative values lie in the interval, and 5 means last ending point is, the starting point is minus infinity. Minus infinity means all the negative values you taken, and 5 means the ending point is 5. 5 means before 5 up to 4, 4.1, 4.2, 4.3, 4.9 up to we take. So suppose I take the x equal to 4 means I substitute x equal to 4 in the small f dash of x. So our answer come to the minus. Minus means strictly decreasing, and next second interval 5 comma infinity. 5 comma infinity means that means the next number of the 5 is 6. So suppose x equal to 6, I substitute in the f dash of x, so our answer is negative answer. We get the negative answer. So I represent strictly negative means it is strictly decreasing, plus means it is strictly increasing, so strictly decreasing. Therefore small f of x is strictly decreasing on minus infinity comma 5 and 5 comma infinity. Since there is no sign change in f dash of x when passing through x equal to 5, there is no local extremum. So here minus no any changes, no any sign or change. So no sign or change means no local extremum. So next third subdivision, f of x equal to e power x by 1 minus e power x. So now I write the given function f of x equal to e power x by 1 minus e power x. I differentiate both the side f dash of x equal to, so here the functions in the numerator by denominator, so I apply the u by v method. So first I square the denominator, 1 minus e power x whole square, so 1 minus e power x, I differentiate the e power x minus, next I write the e power x numerator term e power x, and next I differentiate the denominator. Differentiation of 1 is 0 minus differentiation of e power x is e power x, so minus e power x. So in the next step e power x, I multiply the e power x in the factor, so e power x into 1 e power x minus e power x into e power x e power 2x, next minus into minus plus e power 2x by 1 minus e power x whole square. So therefore f dash of x equal to, so here e power minus 2x plus 2x cancelled, so e power x by 1 minus e power x whole square not equal to 0 for all x belongs to R, and f dash of x does not exist at x equal to 0. So therefore f dash of x does not exist at x equal to 0, because we substitute here x equal to 0 means e power 0, e power 0 means 1 minus 1 0, 1 by 0 is infinity, so f dash of x comes to infinity. So for that reason, due to this reasons, I tell that f dash of x does not exist at x equal to 0. Therefore there is no stationary points, but there is a critical point at x equal to 0. So I marked the critical point 0 in the number line, minus infinity to plus infinity, I marked the 0. So in the interval is minus infinity to 0, 0 to infinity. Therefore f dash of x equal to, we know the f dash of x e power x by 1 minus e power x whole square. So now I write the interval, I make the table, that means the interval is, I write the first column is interval, second column is sign of f dash of x, third column is monotonicity. Monotonicity means increasing or decreasing, we mentioned that. So first I write the two intervals, minus infinity comma 0, 0 comma infinity. Now I substitute any values from this interval, like its value. Suppose I take the x equal to minus 1, I substitute here. So x equal to minus 1 I substitute here, means I get the that means plus values. So plus value means I represented strictly increasing. X equal to minus 1 means e power minus 1, so e by here e power minus 1, so it comes to positive values only, positive answer only, so strictly increasing. Next 0 comma infinity, I take any values from this interval. Suppose I take the x equal to 1, so I substitute here x equal to 1 means 1 minus e, so here numerator e by 1 minus e whole square, again comes to positive answer, so I represented plus. Plus means I tell the I intimate, that means here I mentioned that is strictly increasing. So f of x, small f of x is strictly increasing on minus infinity comma plus infinity, so both the intervals are strictly increasing. Since there is no sign change in f dash of x, small f dash of x, when passing through x equal to 0, yes, because you see this table, no sign change, because plus no any alternate sign, that means minus sign not here, so no sign change. So no sign change means no local extremum. Sign change only, it gives the local extremum. No sign change means no local extremum, so I represented here there is no local extremum. Next, fourth subdivision, f of x equal to x cube minus x cube by 3 minus log x. So I write the given function f of x equal to x cube by 3 minus log x. So differentiate f dash of x. I differentiate the given function f dash of x equal to, I differentiate the x cube 3x square by 3 minus, I differentiate the log x 1 by x. So 3 cancelled, x square minus 1 by x. Next I just doing the cross multiplication. X into x square is x cube minus 1 by x. So the next step I take f dash of x equal to 0. So f dash of x equal to 0 means x cube minus, then that means this function equal to 0. So x cube minus 1 by x equal to 0. So the numerator equal to 0. Whole function, that means this x tends to right hand side, it comes to 0. So x cube minus 1 equal to 0. This minus 1 I write in the right hand side, plus 1, x cube equal to 1, x cube equal to this 1 I write 1 cube. So the next step, this 1 cube I write in the LHS, so minus 1 cube. So x cube minus 1 cube equal to 0. And here, and from this I write the formulas, that means a cube minus b cube. A cube minus b cube means a minus b into a square plus ab plus b square. That formula I apply here. So a is here x, b is here 1. So a cube minus b cube, so a minus b, x minus 1 into a square, x square plus ab. Ab means x into 1, x plus b square. So b square means b is a 1, 1 square is 1, here 1 will come. So plus 1 equal to 0. In the next step, here there is a 2 factor, x minus 1 is a factor, x square plus x plus 2 is a factor. So x minus 1 equal to 0, x square plus x plus 1 equal to 0. So here this here is not possible, x equal to 1. So f dash of x does not exist at x equal to 0. So there is no stationary point, there is a critical point is x equal to, that means x square plus x plus 1 equal to 0 is not possible. This is not possible. So I consider x minus 1 equal to 0 means x equal to 1. Therefore the critical point is x equal to 1. But here no stationary points. So next, f of x lies only on 0, infinity, but f of x is not defined on minus infinity, 0. So here the critical point is only 1, x equal to 1 is a critical point. So f of x lies only in the 0, infinity. So f of x is not defined in the minus infinity, 0. So 0, infinity, I take the number line between 0, infinity, I represent the 1 here. So the interval is 0, 1 and 1, infinity. 0, 1 means, so the f dash of x is x cube minus 1 by x. So I make the table interval sign of f dash of x monotonicity. Interval means 0, 1 and 1, infinity. Sign of f dash of x is, so I take any values between the, that means 0 and 1. Suppose I take the x equal to 1 by 2, 0.5. I substitute here, I get the answer minus value. So I represented by minus. Minus means strictly decreasing. Next to 1, infinity. 1, infinity means I take the x equal to 2. I substitute here. So x equal to 2 means 2 power 3 minus 1 by 2. 2 power 3 means 8. 8 minus 1, 7. 7 by 2. So 7 by 2 is a plus the answer. So plus sign. So plus means strictly increasing. So here, so 0, 1 is strictly decreasing. 1, so f of x is strictly decreasing in 0, 1, and f of x is strictly decreasing. That means here strictly decreasing in 0, 1, strictly increasing in 1, infinity, and there exists a local extremum because the sign change, minus f of x changes the sign minus to plus. So there exists a local minimum at the point x equal to 1. So the local, next time we find out the local minimum value. Next, fifth subdivision, f of x equal to sin x cos x plus 5. This is a plus 5 only, x is a limit, here comma will come. Okay, f of x equal to sin x cos x plus 5, comma x belongs to 0, 2 pi. So this is a function. So I write the first step, I write the function f of x equal to sin x cos x plus 5. Next, this is a sin x cos x. I multiply and divide by 2 by 2 sin x cos x, 1 by 2 into 2 sin x cos x. I write it sin 2x because sin 2x is 2 sin x cos x. So instead of 2 sin x cos x, I write sin 2x. So 1 by 2 into sin 2x plus 5. The next step, I differentiate the f of x. I differentiate, that means I differentiate the derivative. So f dash of x equal to 1 by 2. I differentiate the sin 2x. Differentiation of sin 2x is cos 2x. Differentiation of 2x is 2. So next plus differentiation of constant is 0. So 1 by 2 cos 2x into 2. 2's are cancelled. So f dash of x equal to cos 2x. Therefore, the next f dash of x equal to 0. I take f dash of x equal to 0. F dash of x equal to 0 means cos 2x equal to 0. So cos 2x equal to 0 means cos. So next cos 0, that means 2x equal to 0 means 2x equal to cos pi by 2, that means cos n pi by 2 is 0. So 2x equal to pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2 are it, that means cos n pi by 2 0. So I represented 2x equal to pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2. Therefore this 2 I write in the RHS. So it comes to division. So pi by 4, 3 pi by 4, 5 pi by, it is this 2 right in the denominator. So pi by 2, already there is a 2 into 2 pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. So x equal to, so I take up to 7 pi by 4 because the limit is 0 to 2 pi. So we take only this 4 limit, 4 values. So next is the stationary points. So the stationary points are pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. Now I represent all the angles in the number line. So 0, pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. So next the intervals are, so I take the intervals 0 to pi by 4 first interval, next interval pi by 4 to 3 pi by 4, and 3 pi by 4 comma 5 pi by 4, 5 pi by 4 comma 7 pi by 4, and 7 pi by 4 comma 2 pi. These are the intervals. Next intervals, I make it the table. Intervals, sine of f dash of x, monotonicity. So intervals means 0 pi by 4, pi by 4 comma 3 pi by 4, 3 pi by 4 comma 5 pi by 4, 5 pi by 4 comma 7 pi by 4, pi by 4 comma 2 pi. So 0 comma pi by 4 is, I substitute, I take the limit from this, I take the any interval from this, I substitute in the f dash of x, I get the plus sign, so straightly increasing. Again I take any value from this, I substitute in the f dash of x, I get the, this interval gives to negative answer, so strictly decreasing. This interval gives to plus answer, so it is strictly increasing. And this interval gives the negative answer, so strictly decreasing. And this interval gives to plus answer, strictly increasing. Any value substitute from this interval, any limit we take and substitute in the f dash of x, it gives to plus answer, so strictly increasing. Therefore f of x is strictly increasing on 0 pi by 4, 3 pi by 4 comma 5 pi by 4, and 7 pi by 4 comma 2 pi, and strictly decreasing on pi by 4 comma 3 pi by 4, and 5 pi by 4 comma 7 pi by 4. So therefore f dash of x changes from positive to negative when passing through x equal to pi by 4, 5 pi by 4. So the f of x's local maximum is x equal to pi by 4, 5 pi by 4, and the local maximum value is f of pi by 4 is 1 by 2 sine, I substitute this value in the given function, so 1 by 2 sine 2 into pi by 4. So 2 divided by, that means the 2 and 4 cancelled, so I write it 1 by 2 sine, that means pi by 2. So I write it, that means I write it 1 by 2 sine 2 pi plus pi by 2 plus 5. So I write 1 by, that means I write it 1 by 2 sine pi by 2. This is, I cancel this step, not need. So you take the, that means this 2 and 4 cancelled, so pi by 2, 1 by 2 sine pi by 2 plus 5, sine pi by 2 is 1, so 1 by 2 plus 5, 1 by 2 plus 5 means we doing the class multiplication. 2 5s are 10, 10 plus 1 11, 11 by 2. So also since f dash of x changes from negative to positive, next again a sign changes from negative to positive. So negative to positive when passing through x equal to 3 pi by 4, 7 pi by 4. So the local minimum at x equal to 3 pi by 4. So local minimum at x equal to 3 pi by 4 and 7 pi by 4. So and the local minimum value is f of 3 pi by 4 is 1 by 2 sine 2 into 3 pi by 4. 2 and 4 cancelled. So 1 by 2 into minus 1 plus 5. So just minus 1 by 2 plus 5, 9 by 2. Therefore f of 7 pi by 4 is 1 by 2 sine 2 into 7 pi by 4. So it is a plus 5. 1 by 2 sine just 7 pi by 2 plus 5. So the next step I write it 7 pi by 2 means I write it 3 pi plus pi by 2. So 3 pi I write it, that means 3 pi again I write it 2 pi plus pi by 2. 2 pi by 2 pi plus theta is again sin theta. So sin of pi plus pi by 2 plus 5. Again sin of pi means minus sin. So that means sin of pi plus pi by 2 means again I write it 1 by 2 sin 3 pi by 2 plus 5. So sin of that means sin of pi plus pi by 2 means minus sin pi by 2. So sin pi by 2 means 1. So minus 1. So 1 by 2 minus 1 plus 5. Therefore minus 1 by 2. Here 1 by 2 will come. Minus 1 by 2 plus 5. So here 2 will come. 2 5s are 10. 10 minus 1 9. 9 by 2. Therefore local maximum is 11 by 2. Local minimum is 9 by 2. We complete the class.